Okay, so we are going to go over a day 2 for packet number 2. So the first thing I would like to do is look at that mini mock exam and look at the derivative questions. This is something we didn't get to last time in class. So let's look at numbers 4 and 5 first. We'll need the green sheet as well. Yeah. So go ahead and look at numbers 4 and 5, check your answers, and then I'll take any kind of questions. These were pretty cut and dry. Most of the mistakes here were computational, number crunching. Just as a reminder, this whole key is online. If you can't find it, just email me and I'll email it to you. But we're going to go over it a little bit at a time. Okay, any questions about 4 and 5? So with 5, you had to do product rule first because this is f of x times g of x. So f prime times g plus f times g prime. And since they're asking us for h prime of 2, we plug 2 in everywhere there's an x and we look up all those numbers in the table. So like, for instance, f prime of 2, we look in the f prime column in the 2 row, and that's a 6. Okay. So on 4, once you get the derivative and plug in 8, you got to figure out what is 8 to the negative 1/3. So the negative means we're going to do reciprocal, so 1 over something. That's what a negative exponent does. The 1/3, that's a cube root. So the cubed root of 8 is 2, but since that's a negative 1/3 power, we're going to write it as 1 over 2. And then multiply it to the 2/3 to get 1/3. Okay, any other questions? Okay, let's look at the next page. And we are going to skip 6, 7, and 8 for another day, but let's look at 9. 9, this is kind of weird. 1 only should not really be there. I cut off the problem too soon. When this says which must be true, we really should have said Roman numeral 2 and 3 must be true. Okay, 1 was actually the only one that could have been false. It could have been true, could have been false. If you didn't understand, or if you didn't kind of connect that these were IVT and MVT, that's okay. You could still kind of reason through that those had to be true, having to do with like the slope between the 2 points and the fact that you have to cross the x-axis if f is continuous. We're going to review the theorems we're going to do that later. It's going to be one of the last things we do because I want it to be really fresh in your mind before the AP test. We're reviewing it a little along the way, but like we're going to really practice those like late next week. Okay. Maybe early next week. Anyway. All right, number 10. Okay, I did a lot of work. I think I must have not had my calculator with me when I first started doing this. I don't know. But if a question like number 10 is on the calculator part, because you got to have a calculator to do the last step, you might as well use the calculator to do all the easy stuff for you, like find the derivative and simplify it. Solve that equation. You know, use your calculator for that. There's a section on your green sheet for calculator steps. You need to write on there what you need to do, but more than that, you need to practice the calculator steps. If during the AP test you're like, I don't know why I'm getting an error here. I don't know where the comma x should go. That's on you. We've practiced this all year. You've got to be really comfortable with that 89. Okay, any questions on these? Can anybody tell me which theorem is represented by setting IROC equal to AROC? Mean value theorem. Remember, another word for mean is average. Average rate of change. That's the connection there. That's the way you can remember that. Okay, let's turn the page. And I want to look at 12 and 13 now. We're skipping around because I really just want to look at the problems that have to do with derivatives. 13, a lot of people asked me about 13 after the fact. They got stuck on this one. If you're talking about tangent lines, then you got to be talking about derivatives. So finding y prime, that was a necessary step. Okay, parallel, same slope. So find the slope of that line, set it equal to the derivative, use the solve feature to solve for x. Excuse me. What is 13? What type of problem is 13? Yeah, related rates, or Fuigi, okay? We are going to look at another one of these problems here in just a minute, but I wanted to go ahead and show the answer and show the work here if there are any questions. All right, well, let's put the mock exam away, and we will look at that later on when we go over another packet. For now, I would like for you to look at number 18. Oops, not too far. So hopefully you did 1 through 15 in class Friday or over the weekend. That was what you were supposed to do. Your classwork and homework tonight is just going to be to finish this packet, which is about the same length. But I wanted to look at 18 with you, okay? And again, I know this is blurry. If you're watching this video, you should be really looking at the packet right now because I know the video is kind of hard to see right here. All right. Look at this statement right here. G of x equals f, and then there's a -1. What does that mean? Okay, if we have a number to the negative power, it means reciprocal 1 over it. But if we have a function to the -1, it means something more complicated than just the reciprocal. It means inverses. All right, and now we learned this back in December, and then we reviewed this actually with chapter 5, but it's something that's easy to forget. If you know that g of x and f of x are inverses, and you want to know what the derivative of g of x is, g prime of x, it's going to be 1 over, so the 1 over is in there. F prime, so the inverse is derivative, but not of x, of g of x. Okay, this would be a great thing to write on that green sheet. I don't have it on there because honestly, this type of problem, if there's even one, it's going to be 1 on your test. Okay, it's not like a very common topic on the test. If you know you're horrible at memorizing and your goal is to get a solid 3, this may not be something you really need to study. I think your time is better spent somewhere else, okay? All right, but let's go ahead and go through this problem. So we're looking for g prime of 3 in this case. So we're going to do 1 over f prime of g of 3. Okay, now they do not come right out and tell you what g of 3 equals, but they give you information to find out. And it has to do with inverses again. So look right here where this says f of 3 equals 15. What that means is that g of 15 equals 3. That's what inverses is. You just switch the x and y. So that didn't really help me here. But what about this one? If f of 6 equals 3, g of 3 equals 6. So you had to kind of take that next step to figure that out. And then what's f prime of 6? -2. Okay, so those are kind of weird problems. And again, not very common at all. There's really only one other inverse derivative problem on this packet. And you'll get to do that one on your own. Okay, already kind of mentioned this, but 26, This was on our other packet exactly. So we're going to skip that one because we already did it. Okay, again, I know that this is really small, and what I'm saying right now is more for the people watching this video who are absent. You should be looking at your actual packet instead of trying to read those words up there, because that's obviously really small. But I'm doing the video this way so that we can at least know where this goes in the packet. Okay, what type of problem do you think this is? And you can look at the heading if you're not sure. Related rates. What in the problem, though, would tell you that this is related rates?
Meters per second.
We see some meters per second. We see some rates of increase. And
Intersection.
we do see an intersection. So let's draw that intersection, because this is how most related rates problem are going to start, which is with a picture. Okay, and we're looking at this from an aerial point of view. Okay, here's the intersection between the train tracks and the train tracks are going east and west, and like a road. Where's the observer? 70 meters south. So here's the little observer, and that means that from the middle right here down to this point, that's 70 meters. We're going to title this or label this picture so you can help us set up the problem. And then it says there's an eastbound train traveling at 60 meters per second. So the train is traveling from west to east. So I'm going to put a little arrow there, and we'll say the train is right here. And they tell us how fast that train is going. 60 meters per second. So I'm going to go ahead and write that on the picture as well. I don't know how long this is, but maybe I can figure that out with some additional information. Then it says that how many meters per second is the train moving away from the observer? So keep in mind, the observer's down here at south, the train is over here at east. So what we need to do is connect those two things. And what shape have we just made? Specifically, what type of triangle? A right triangle. So in setting up our Fuigi, we're probably going to use Pythagorean theorem. Now, it may be something else, but this is kind of lending itself to knowing information about the three sides. So let's go ahead and call that A, B, and C. It doesn't matter what letters you use, but if you're going to use Pythagorean theorem as A squared plus B squared equals C squared, then you got to make sure C is in the hypotenuse. All right, let's see if there's anything else that we missed. What are they asking us to find here? The rate of change of C, and so we're going to write it as dC over dt, the derivative of C. So in the end, when I take derivative of C squared, I'll have a dC over dt, and that's what I'm looking for. Okay, is there any other information that they give us? We got 4 seconds. How is that going to help us? So if the train is moving 60 meters per second, how far is B if we're talking about 4 seconds have passed?
15 meters. Wait,
So what would we do with the speed and the time? If it's 60 meters per second, that's 60 meters every second. So if we multiply those two, we get 240, and that's how many meters the train has gone. And we need that. And we need to even go further because we need to find C as well. When I take derivative of this Pythagorean theorem, I'm going to have C in there. You can do Pythagorean theorem, or you can recognize the triple. So we know the 3, 4, 5 triple. Probably you know the 5, 12, 13. Do you know the 7, 24, 25 triple? So if not, then you got to do Pythagorean theorem. This is a calculator problem, so that really should not be that difficult. But I'm going to go ahead. I do know the triple, so I'm going to go ahead and write that down. That saves me some time and some work. If you didn't know that that was 250 in your head, then you had to go off to the side and go 70 squared plus 240 squared equals c squared and so on, okay? All right. There's one more thing we might need to find, but I'm going to let you guys tell me what it is after we derive here. So we're going to take the derivative with respect to time. Now, I'm going to write big and kind of go down here just because so that you guys can see it. So just keep that in mind. It's going to be a few lines. So 2a, and since I'm deriving with respect to t, I need to go dA over dt. Okay. Do you know what would be next? Okay, so go ahead and write it down. Just going to take derivative of each piece. There are some related rates problems that are no calculator. Okay, just so you know, this is not one of them. If it's no calculator, though, what could you do to make the number stay smaller? Yeah, yeah. We're going to get to that other thing in just a second, but we're going to cross off the 2's. Now, in this case, I don't know if that really makes it any easier because we're going to do the calculator to crunch the numbers anyway. So we know A is 70. We never wrote down, excuse me, we never wrote down dA over dt.
It's not moving.
Yeah. The observer is 70 meters from the cross section today. Tomorrow is forever as far as we know. So dA over dt ends up being 0. And that happens a lot in these right triangle problems where one of the sides has a rate of change of 0. So if you're getting stuck, that could be why. And I'm just plugging in all the numbers. And dc over dt is what we're looking for. So from here you have a couple of options. You can just use algebra to isolate dc over dt. You can use the solve feature in your 89. So go ahead and figure out which decimal dc over dt is equal to.
Why we get rid of dA over dt and dv over dt and not use c?
I'm taking the derivative of a squared. Okay, just like when you, what's the derivative of x squared? Okay, that's what I'm doing here. I'm taking the derivative of a squared, but because I'm taking derivative with respect to t, I got to go dA over dt. It's just like when we do implicit differentiation and we got to go dy over dx. It's in related rates problems, you're always going to have that. After you take derivative of any letter, it's going to be d that letter over dt every time. So if this was a radius, you'd have dr over dt.
Sorry, I was just confused. So dA over dt is 0 and dv over dt is 60.
Yeah.
Yeah, I was just confused.
Oh, sorry. Okay.
Sorry. Thank you.
Okay. Okay, what are we getting here? If it's taking you longer than that to type something in, then you're doing something wrong. A, 57.6. Time management is going to be a big key on this test. You cannot sit there and fiddle with your calculator forever. It's just a waste of time. You need to be really comfortable with it. Okay, so your classwork/homework is to finish this packet. All right.